Hello everyone and welcome to another Stat 437 lecture video. In today's video we're going to be taking a look at implementing or opening up some longitudinal data in R and working through it, looking at what the data looks like, looking at some different ways that we can plot it and visualize it and start to get a hands-on feel for how we're going to use real data in this course. So this is a complement to the first lecture in which we discussed what longitudinal data are, the types of questions we're going to try to answer with them, and that type of thing. And so in today's video, we're really just going to open up a data set and explore it and see what do longitudinal data really look like. So with that, I'll open up RStudio. Now, I'm assuming that all of you have R installed or RStudio or at least somewhat comfortable with it. If that's not the case, please let me know and I'll help get you started on this. The other thing is all of the code from these videos, while I'm going to sort of work through it in real time here, is also posted on the site alongside any data. And so if you want to download that code for yourself and just read through it, you can do that. So the data that we're going to be looking at today is the TLC data that I was discussing in the last lecture. And so the TLC was a study that looked at lead in the blood of children. So it was the treatment of lead in children, I believe is what TLC stands for. And so it was just a longitudinal study that compared two different treatments or an active treatment to a placebo for the lead levels in the blood. And so we'll take a look. It's a fairly simple example of a longitudinal study. And so the first thing that I want to do is just actually read in the data. So to do this, I'm going to define this TLC variable here. And I'm going to call read CSV, which reads in a CSV file. And the data for me is stored at data/TLC/TLC.csv. Now you'll have to swap out this string here for wherever your data is actually stored, but I can call that and that should be now stored in this TLC variable. If I call head, it will print out the first 6 rows of this data, and we can see that it's a fairly simple data frame that we're looking at here. So we have this ID column, a treatment column, and then W0, W1, W4, and W6. And these W columns stand for week 0, week 1, week 4, and week 6, and those are actually the measurements of the lead levels in the blood. This treatment is either placebo or active, so a P or an A, and then the IDs uniquely define each individual subject in the study. So the basic idea with an analysis of this study here is sort of we want to think about time trends of individuals, so how does the level change over time, but we also want to differentiate between those who received placebo and those who received active treatment. And so the first thing to note about this data here, at least as it's written, is that each subject, so each ID corresponds to an individual, a single person in the study, and each ID gets exactly 1 row in our data as it's expressed here. And so for each person, we have a column representing all of the longitudinal measurements of the outcome of interest. So in this case, the lead levels in their blood, right? And so here we had 4 different measurements, and so there are 4 corresponding columns of these measurements, and that's all stored on a single row. So when we're thinking about longitudinal data in practice, we can either think about it as being a wide format data set or a long format data set. This would be an example of a wide format data set, and here when we're talking wide versus long, we're thinking, do the longitudinal measurements get stored in the same row, at which case it makes the data file wider than it otherwise would be, or do they get stored in separate rows, at which case it gets longer? And so what would that look like? Well, instead of having 1 row for ID number 1 here, we would actually have 4 different rows, right? And so we would have a row for this W0 value, we would have a row for this W1 value, we would have a row for this W4 value, and we would have a row for the W6, and then same thing for person number 2. So instead of having 100 rows in this data set, we would have 400 rows in this data set, and each row then is one measurement from one person. Okay, and that would be called a long data set. Now, the reason that we care about this is twofold. The first is that when you get a data set from somewhere, these are the two formats you're most likely to see them stored in, and you're not really sure which it's going to be, and so being comfortable with working with both and converting between the two is quite important. The second is that different modeling software in R, so we're going to fit a bunch of different models throughout this course, are going to expect the data to be in different formats, and so you need to be able to move smoothly and fluidly between these two different formats. And so I'm going to spend a little bit of time talking about how we can reshape our data to be either wide or long. And I'm going to go into some amount of detail here, and I apologize for any of you who have seen this before, but it's really important that you feel comfortable getting a data set, determining whether it's in wide or long format, and then moving between those two, because we're just going to sort of, after this point, expect that that's something that you're able to do. And so we clarified that we had a wide data set. And so if I want to convert this to a long data set, if I make this TLC long variable here, I can make use of the reshape function in R. Okay, so the reshape is going to reshape from either long to wide or wide to long. And so we need to specify a number of different parameters depending on whether we're moving from wide to long or long to wide. And so in this case, we're going from wide to long, and so I'll talk through that. The first thing that we want to do is provide the data. And so this is just going to be a data frame. In our case, it's going to be TLC, because that's what we're working on. So nothing too interesting there. The next is that we want to specify varying. So varying is going to be a vector of columns in our data frame. And so I'm going to pull this up here, actually view the data here. And you can see that we have 4 columns here that are the columns that vary over time. So this varying parameter takes in a vector that contains the names of those 4 columns. In our case, if you had more columns than these, you'd want to include those other columns as well. And so these are the columns that actually vary over time. So for us, it's going to be W0, W1, W4, and W6. So we pass those to the varying keyword here. The next that we want to provide is times. And so this is going to be a vector. And the idea with times is that it matches on to varying and specifies the value of time at each that's stored in each of these columns. So W0 represents week 0. And so if we want our times to represent weeks, then we could store this as 0, and then 1, and then 4, and then 6. But we could do this sort of however we want to. So if we actually wanted to measure in days, then perhaps we would do, 0, 7, 28, 42. And now we're measuring in days, for instance. I think weeks makes more sense based on what we have, but the idea is that this 0 corresponds to whatever the time point at W0 is. The 1 corresponds to whatever the time point at W1 is, and so forth. So after we've specified times, we want to specify the ID variable, ID var. And so it's going to be ID for us because in this case, our ID is stored in sort of the capital ID column. And the idea with our ID is just that it is a unique identifier of the individual row. Okay, so we specify the ID var. We also want to specify the direction. So in this case, the direction outputs whether we are going to long data or to wide data. So in this case, we're going to say direction equals long because we want to output this as long data. The last thing that I want to provide for sure is the time var variable. And the time var variable is just what is the name that we're going to give to the column that includes the times in this newly outputted data frame. So for us, because we measure times in weeks, I think it's natural to call time var equals week. And then we'll see in the outputted data frame, there's going to be a column that has the value of week. And that's going to include the values of all of the times. Okay, so if I run this, oh, and I'm actually missing one additional parameter here, and that's sep equals no space. And I'll explain what this is in 1 minute here. If I read now, we see that that actually works out. So what happened there, and we can pull this up and I can show you, it's failed to guess time varying variables from their names. The problem is it's trying to read off the values from these varying columns, so W0, W1, W4, and W6. And so it wants to guess what is the actual sort of which of these columns correspond to which time points. And so in order to do this, it's reading these names and trying to associate them to different values. But if we take a look at this TLC long file here, you can see that we have this W column. And the idea is that W0 corresponds to the value from our W0 column. And then if we sort this by the ID instead, now W1 is the value that was in W1. And so this sep argument here is just going to say, how are the column names separated between the name of the value, which in our case is W, and the indicator of the time point here. So that's going to be 0. So if we take just a brief look here, we can see now that we have this long formatted data frame. So instead of there being one row for each ID, we now have 4 rows for each ID. So you can see ID 1, week 0, ID 1, week 1, ID 1, week 4, ID 1, week 6. And these values that are in this W column are going to correspond to the values that were in the row before. Okay, so we have gone from what was a wide data format to what is a long data format. Okay, and so this code here, I would encourage you to play around with it and sort of explore exactly what these properties represent, because again, you're going to need to be comfortable doing it. But to reinforce this and show you sort of the complete idea, we can also reshape from long to wide. So here, we're going to go reshape. And we start by specifying the data as well. And so in this case, we want to produce a wide one. So we'll start with TLC long. Now we don't provide varying this time because we don't actually have columns in here that correspond to the varying values over time. Those are stored in rows. And so instead of varying, we have to provide vnames. And vnames is just the names of the values. And so in this case, we have this column W, which includes the values that do vary over time. And so we provide vnames equals W. We need to provide the ID var again. So ID var is going to be ID. And we do want to provide this times as well to indicate, to sort of recreate these column names correctly. So we're going to end up producing the times in the same way. We want to provide the time var. In this case, it's week. And instead of it being the column that's going to produce, we need to make sure this matches where our time variable is actually stored. And we want to provide the direction again. In this case, we're not going direction long. We want to go direction wide. And we want to provide the separator, which is going to be the separator when we're actually creating our new names. And so really the big difference between these two calls here, well, we switch the direction, of course, from long to wide. And instead of providing varying when we're going from our wide into our long, we want to provide vnames instead. So I believe that I should have everything specified there. If I run that, I can open this up, this TLC wide, and you can see that we essentially have what we started with now. So for each ID, there's exactly one row, and we see these W0, W1, W4, and W6, and all of those sort of represent the values that you might expect. So I want to spend just a few seconds longer talking about some of these parameters, because what I've shown you here will work, certainly. But I think that actually I've been a little bit less than perfectly clear about how this is working, but now that we have this all typed out here, where we have our wide and our long conversions going, we can see this. So the first thing that I want to do is sort of show when we're going from a long to a wide, how are these new values being constructed? And so the idea is that if we have our long data frame, this vnames is going to be the name of the value column. And when we are creating the wide columns, the columns in this newly created wide data frame, it's going to take vnames, it's going to attach the separator to it, and then it's going to take the value from times. Now, what it's actually going to be doing is it's going to be reading this value directly from week. So I can comment this out, say, and if I go put in a separator of an underscore, and I run this, and we go back into our TLC wide, you can see now that we correctly gave w underscore 0, w underscore 1, w underscore 4, w underscore 6. And so we didn't actually need to provide this times, because in our long data form, the times were correctly specified. And so I can have here, and you can see it's grabbing W0, where the 0 is coming from the week here. The sort of same thing is true when we're going from wide to long. And so if I comment this out and I rerun this, we're actually going to get the same output here, right? And that's because when we're in our original data set, we have W0, W1, W4, and W6. So if instead of using sort of the implied values from our columns, right? So we're getting W and 0. If we wanted to very clearly specify, actually these columns don't have the time built into them. So, if instead of in these columns it was W0, W1, W4, and W6, these were just different, letters. So A, B, C, and D, for instance, right? Then there's not going to be this way for it to extract, okay, this is time 0, this is time 1, this is time 4, this is time 6. And so we need to be able to specify what those times are. And so if we wanted to overwrite this, we actually need to provide not only times, but we also need to provide vnames. And so what I'm going to do here is I'm going to say, let's provide vnames, and the value is going to be, say, lead level, right? That's what we want the new column to be called. And instead of providing times as 0, 1, 4, and 6, why don't we say we're measuring it out in days? So we'll go 28 and 42. Okay? And so what's going to happen now is these times are corresponding to the different columns, as I had expressed before. And instead of reading W and creating the variable name from W, we're going to create a new variable called lead level. And we should update this to, instead of it being week, it should be day, say, for instance. Okay, so if I call this now and we open up this long, you can see that we have lead level instead of W. And our days are going to be 0 for the first bit, but if I instead sort by ID, you can see we have 0, 7, 28, and 42. But these still correspond to the same first 4 measurements for this ID 1, right? Now, when we're going to go convert back, if we just try to call this now, right? So if we come back and we just call here, you can see that we're running into issues. And the problem is that we have undefined columns. So now instead of it being W as our vnames, well, our values are now stored in this lead level variable, right? If we, our ID var is still the same, instead of it being time var of week, it's going to be a time var of day. And the direction wide, and let's still use this separator of underscore here. So I can run this, and this is going to work now. And what we're going to get now is the lead levels built up with the day values instead. So lead level 0, lead level 7, lead level 28, lead level 42. Okay. So I would really encourage you to play around with this and experiment with the different parameters here, because there's sort of endless ways of getting the data to look the way that you might expect it to. Now, with all of this said, I'm actually going to produce the long data format based on what we had originally discussed. And so this should be called week again, and we can just let it determine everything for us. And then I'll produce the wide one based on, that should be a W now. The time bar is week, and that should run. And now we should see back to what we expect again. But so hopefully that was sort of a fairly in-depth way of using this reshape function. Again, you should feel comfortable using this function to reshape the different data that you're looking at. But ultimately, the idea is mostly, expressing, we're expressing the same data in multiple different ways of organizing it. And hopefully that's clear. If you have any questions at all, of course, please ask me. Now, moving on, we want to look at some different plots here. And so I'm going to quickly run through a handful of different plots that we might enjoy looking at. And this is just to sort of start getting a feel for what these types of data look like. So the first one that I want to do is I just want to do a box plot. And with most plots in R, we can plot using a formula. And so I'll go W, which is our outcome variable if we're talking about the long data now. So for most of these, I'm going to use the long data. And I want to do it based on, say, week plus treatment. And we'll take the data from TLC long. And so what this is going to do, if we actually take a look here at, I'll make this plot quite a lot larger over here. You can see that we now have a box plot where we see for the treatment A, so the active treatment, weeks 0, 1, 4, and 6, and then same thing with the placebo treatment, 0, 1, 4, and 6. And if we wanted to, we could add in a vertical divide here. So I can go AB line V equals 4.5, and that should divide these up. And so now we have this right-hand portion being the placebo group, the left-hand portion here being the active treatment. And so you can just start to get a sense of looking at the different patterns here. And so clearly these two treatment groups have differing patterns, right? So we see in the active treatment, there's this big drop from weeks 0 to 1, and then we see sort of actually an increasing trend. And in the placebo group, things seem more or less stationary, right? We also see that there's quite a lot of variability over in this placebo group, so perhaps we might be looking at, something of an outlier, right? We have a point up over 60 here. It's the only point in the data set that's anywhere near that. But, so we can sort of start to get a feel for that. If instead of looking at box plots, we wanted to use line plots, there's a package in R, and it's called Lattice, and it's quite handy for looking at these things. And so if you don't know, you can call install packages and then pass in a package name. So I can type Lattice here, and it will install it. I already have it because I installed it beforehand, but you can do this, and this should install it for you. And so if you can, and then to use a package, you can either call library and then call Lattice here, and that's going to load in the package. Or if you don't want to actually load in the full package, you can sort of use this format of Lattice and then 2 colons, and that's going to let you then call a function from that. So the function we care about here is xyplot. And here what we're going to do is we're going to provide it a similar formula. So we're going to say W explained by the week. And then we're going to include this bar here, and that's a conditioning bar essentially. So conditioned on treatment. That's going to basically group us on that variable. The data is going to still be from TLC long. We want to pass in groups, and that's going to be grouped based on ID, right? So each person is going to be its own group in this case. We'll pass in a color of black, and in terms of type, we want both line and point, say. Okay, so that's sort of what we're doing here. Now, if I run this code, you can see that we have these somewhat messy plots over here, but they're divided based on this grouping of the treatment, so active and placebo. And for each individual in this data set, we see a line being traced out. And so there's going to be, each one of these sets is a person that we can trace through the data set there. Okay. Now, this plot is quite challenging to read. There's a lot going on here. In fact, when you sort of do this, it's oftentimes referred to as a spaghetti plot because it just looks like a plate of spaghetti. It's really hard to track any individual from it because there's too many subjects in this study. And so one thing that we might want to do is just plot a subset of this data, okay? And so maybe we just want to randomly sample some individuals to include on this plot. And so what I'll do here is, this is going to be plotting a subset of the data. Plotting a subset, sorry. And let's say that we want to do 5 different plots. So I'll define plot num to be 5 here. And so this is what we're wanting to do, is select 5 random people and plot their data in this way. Now, the way that I'm going to end up doing this is actually to just use sort of a standard line plot, right? The first thing to do is actually generate our random samples. And so we want to generate 5 random samples for the A group, 5 random samples for the P group. So let's do random samples P, right? And so we can actually do using sample here. And sample is just going to randomly select from a list that we give it. And so the list that we want is actually going to be, say, the unique IDs from TLC long. Okay, so unique TLC long ID. And instead of providing all of the IDs here, we actually only want the ones, this is for our random samples of P, so we only want the ones that are in the P treatment group. So I'm going to subset this to say which TLC long treatment is equal to P. So what is happening here, and let me spread that out so that we can see more of that on this line, is we're taking the unique set of all of the IDs for which the treatment is equal to P. Okay? And so, we could actually take a look at what that is. If we just run it, you can see it's this 50 character long list here, and each one of these individuals in the data set was prescribed treatment P. Okay? And so then we want the size of this to be plot num, so we're going to generate with 5 different plots, and we want replace equals to false. And so with sample, if replace is true, then after you draw out, say, this 1, the 1 is going to go back into the data set again. Okay, so if we run that, forgot to define plot num. So we can do that, and now we've generated this sample. If we go random samples P, we have a list of 5 indexes, 5 IDs for people who received the placebo treatment from this. And if we run this again, you can see random samples P, capital P, it's a different 5 than originally, okay? And so we can do the same thing here, and I'm just going to copy and paste this down for the A group. So change this to A, we're subsetting based on A, otherwise everything's exactly the same. Okay, and now what we want to do is say, let's plot the all of the data points. Okay, so if I think about what plot I actually want to, if we plotted just the points up here, if we didn't plot these lines, so to do this, you can see that this plot isn't actually so bad. This gives us some sense of things, right? And so what I'm going to do here is I'm actually going to come down and I'm going to say, let's say plot W week. The data is going to be TLC long, and we're going to subset on treatment equals P. And then what I want to do is I want to loop through these random indices here. So if I go for random ID, say, in random samples P, what I'm going to want to do is for each one of those random samples, I want to do a lines call. And the lines call is going to be W, described by the week. The data is going to be TLC long. The subset here is going to be ID equals RID, right? Because this is going to be one of those random IDs that we've selected. And I don't believe I actually have to specify the type, but I'll do that to be concrete. The type is L. Okay, so when we call this first part, we see that we've generated a plot which is just the people in the placebo group, and it corresponds to all of the points. And then when I call this loop, we loop over 5 random individuals, and we add their lines to this plot, right? So again, I can copy and paste this, and instead of subsetting on the P here, we can subset on the A. And instead of looping over all of the random samples in P, we can loop over all the random samples in A. And if we do this, we generate this separate plot here. Now, what I would actually like is to have these two plots in one, right? And so I can do, if I call par here, then I can provide mf row, and then this is going to let us plot into a grid. And so if I go mf row 1, 2, and I call this, then what you can see is that this is letting us have one row, two columns with our plots. And so I can do this, and I can drag this over. And now what we're looking at here is the placebo group, the active treatment group, 5 randomly selected lines on each plot. Okay, so that was like quite a lot of code being thrown at you right there, and I'd encourage you to read through it and explore around. But the idea is basically now, instead of these horrible to read spaghetti plots, we have just a few lines, right? Now, the problem is that these lines might not be super meaningful to us because they're just 5 randomly sampled individuals. And so if you generated a few of those and got a sense, you might be able to make some meaningful conclusions about your data. But you also might prefer, instead of it being randomly selected individuals, maybe we would want to select individuals that are somehow representative of the overarching goals in the study. And so one thing that we might want to do here is, say, adding a median, the line of a median individual to the data, okay? So instead of randomly sampling, we could sample the people who sort of, if you computed the median values, then we could sample along percentiles of that distribution. Now, I am cognizant of the fact that we're already sort of running a little bit long in this video. So what I'm going to do is I'm going to copy in some code that does just that, and then we can walk through it instead of writing it out sort of in real time here. And so if I bring this over and I paste this in, there's a lot here. But let's just run through quickly what this actually produces, and then because this type of code, there's sort of endless varieties of ways that we could go about applying this. And so the details don't matter as much as thinking about how can we start visualizing these data. So the first thing that I do here is I compute the median, and I'm working on the wide data frame here. And so what I want to do is I want to get the median of these columns that are specified. Okay, and so I'm applying the function of median. Margin of 1 means that we're working across each row, and so we're taking the median of those 4 values, right? And so now this TLC wide has this median column, and it's going to be the median of these 4 values. Okay, and now what I want to do is I just want to reshape the TLC long again. This time I'm working from the TLC wide, and the only reason that I want to do that is so that now this TLC long also includes a median column, right? And you can see if we sort by ID, the median column is just being repeated based on each individual. All right, so that's just a quick reshaping to compute the median. Now, what I want to do instead of randomly sampling is I want to get these sorted medians for both P and A here. And so what I'll do is I will call sort on the median, but we're sorting on the median where we are looking at the subset of just P or the subset of just A. Okay, and so if we do this and we do this and we take a look, each of these now is going to be all of the different values of the median values in increasing order. Okay, and so the idea is that now what we could do is we could take a look at, say, the people who have the lowest value for their median, the highest value for their median, and say the median value, right? So somewhere in the midpoint over here. And then now what we're doing is when we're plotting some of those lines, so we're overlaying a few lines on it, we can see people who might be somehow indicative of the overarching trends in the data. Okay, so we'll add in these plots, and I will call this plot here and finish generating the plot, and then we can take a look at it over here. So what I've actually done here is I've grabbed the quantiles of these individuals. So these are the people with the highest median, the lowest median, and then sort of the three values in between. And same thing on the other plot here. And you can see the shapes here. So what you might be able to look at and see for the sort of middling individuals, it seems that this person, the 75 percentile individual, has a value that starts quite high, and it appears that that is what is sort of driving their higher value, because otherwise it's relatively flat. And you can see that same thing with the median individual and the lower quartile individual, relatively flat lines here. With the active treatment group, you can see that almost all of them follow a similar pattern, which is you sort of start out higher, you fall immediately in week 1, stay more or less constant, and then in week 6 you've increased slightly again. And you can see sort of a more similar time trend over here, whereas here these people seem to be sort of more constant, with the exception of both the minimum and the maximum. And so again, apologies for rushing through that code slightly, but that's one way that you might be able to overlay some lines that are slightly more meaningful. So the last plot that I want to show you very quickly here is a correlation plot. So we've said that the big difference with longitudinal data as compared to cross-sectional data is that longitudinal data are correlated. And so how might we be able to visualize this? And so we can use the core plot library here. And if I'm going to call coreplot.mixed, and this is going to let me produce a mixed correlation plot. I'll show you what that means in a second. In order to make this plot, the first thing that we have to do is pass in a correlation matrix. And so I'm going to call the correlation matrix on based on this core function, which computes the correlation matrix. And I'm just going to pass in the correlations of the subsetted version of our TLC wide data frame. Okay, so this is going to compute what are the correlations between W0, W1, W4, and W6. All right. And we're going to specify a lower. My lower is going to be number, and we're going to specify an upper, and that's going to be square. And I'm going to generate this plot so that we can actually see what those values look like. We'll let it resize. So the lower, when we say mixed, what we mean is that in the top portion of this correlation plot, we want it to be different than the bottom. So that's what core plot mixed is. And then when we say lower is number, that's outputting the exact correlation on the lower triangular part, and upper is square, that outputs this square shape on the upper. And so the idea here is that we can see how strongly correlated these different measurements are, right? And so you can see, say W1 and W4 have a correlation of 84% or 0.84, right? They're very strongly correlated. You can see that W0 and W1 have a weaker correlation. In fact, that's the weakest correlation that exists. And somewhat, that makes a little bit of sense, all told. And there's some reason that makes sense, mostly because W0 is pre-randomization. And so, these W1, W4, and W6 are all going to be impacted based on which treatment you're at. W0 is taken before then. And so we would expect this to be slightly less strongly correlated with the others. But we can see that if you're assuming that all of these variables are independent of one another, that's very clearly violated from this plot, right? You wouldn't expect to see 0.84 correlation with two variables that are independent from one another. So that's just a good way of sort of visualizing the key trait of longitudinal data here. And so with that, that's essentially all that I wanted to do. So again, I'm posting all of this code, and I would encourage you to download some data from the course website and explore it for yourself. And, just take a look and see, how does all of this sort of work? Can you understand how we're generating these plots? Can you explore what the different structures in these longitudinal data are, and sort of work from there? I hope that this was informative, and sorry if it was a little bit more in depth than what you needed, but with all of that said, we're going to be, sort of assuming a lot of familiarity with working with this data. And so if any of this was over your head or anything doesn't make sense, please reach out and ask, and then that way you can make sure we're keeping up with the R code as the term goes on. So thank you for watching, and I will see you in the next lecture video.